All right, we're getting there. All right. Okay, so we already said it was a parabola in the last video because first of all, this particular form you want the x's and the y's on opposite sides. So every one of these shapes has a little nuance. I would probably just say that the hyperbola and the ellipses are the closest to each other. Now, parabola has its own focus, and there's one of them instead of two that the others have, except a circle doesn't have a focus. Its focus is its center. But he'll have a focus, but that's not the question here. It's just which direction is it opening, okay? So let's see. If the square is on the x, we know that he's got to open up or down. Now that's different than what happens with a hyperbola, so you got to remember that. The hyperbola, x is being squared, they go like this, right? So, and then the y's go like this. So they kind of flip around. You have to, that's definitely something you might want to put on your note card. But with this y being negative, then we know that it's got to be down, okay? And likewise here the x is also, but now the y value is positive. That 1/4, it doesn't tell us what the p value is or what the focus is, so we just know that this guy's going to open up to the up. Okay, he's going to open up because this p value is positive, okay? All right, now normally what we've been doing is we've been putting the square over on the other side, okay, and that was predominantly what our notes involve, but it doesn't matter, so get comfortable knowing that it's logical for both sides like that. Okay, so this is similar to number 27 there. So let's see, we have a vertex of +3 and +1. Oh, 725 already, huh? All right, 3, +1. So he is going to be 3 and then +1 right there. We know that he's actually going to be pointing down because the x is squared and it's negative. So he's going to go down, okay? But we need to know how far down. So let's see. That is a -1, and -1 has to equal 4p, okay? Okay, so 4p equals -1. So let's find out where the focus is. I can actually already see that the lattice rectum is going to be a distance of 1. So half this way, half that way. All right, you guys taking off? Yep, okay. All right, have a good day, guys. All right, let's get the p-value, -1/4. Okay, so he's going to be going down, but he's going to be very, very close to the vertex. So he's going to open up rather wide because the lattice rectum is going to go half this way and half, no, he's not going to open up that wide, and half that way. So he will look something like this. Okay, now remember the reason why it's half is because 4p equals the lattice rectum, okay? 4p equals the lattice rectum. Now the negative sign, just ignore. We know he's already pointing down. So if we go 1/2 for the lattice rectum this way, 1/2 that way, that covers the entire length of this, okay? So look at your notes for other examples, but when the p-value is -1/4, he's going to be very, very close to the vertex, okay? And then the directrix would be 1/4 behind him. They don't ask us to graph it, but when you do graph it, that is very important that you put the vertex, focus, and directrix, okay? All right, this guy, looks like we're at -4. Oh, okay, well, they're not going to just, they're not going to open downward both times. All right, so this guy is -4 here and then +4 here. He's going to open downwards, but he's also going to have the same p-value. Now, that's not going to happen on the test. In fact, I kind of just want to change it. But if you're already this far and you've done it and you want to check your answer, just know that he's going to look like this, okay? But if this was -4, well, then things are going to change, right? Then the p-value is 1. We're going to go down 1, and then we're going to go 1 that way, 1 that way. So anyways, kind of the same thing. I'm not going to change it, okay? But he's going to be very much behind here, just a 1/4. And so this guy would go 1/2 this way, 1/2 that way, and he'll just kind of open up like that. All right. Okay, so here's the focus. Now, what we'll do, oh man, everything is -1. Jeez. Okay, now, is the 4p value on the right side? The 4p value, okay, has to be on the side that is not being squared. So we can actually say that 4p does equal -1 here, okay? Just like over here, he's on the right side, or the correct side, I should say. Okay? So I can actually just literally set up the equation exactly as I see it, okay? So if this is the case then, go up to 40. Okay, good, okay. So here, then, where are we at? 5 minutes. Okay, let me finish these problems. So the p-value here is going to be -1/4, okay? And I know he's going to be going downward, okay? So let me get that vertex, and that vertex is 7, +1, okay? So if I'm going to go downward, I'm going to grab the y-coordinate, and I'm going to subtract 1/4 from 1, okay? So he's going to stay at 7, but he's going to go down 1/4. And the only one that I see that goes down 1/4 from 1 is this guy right here. He went down 1/4, okay? And you can see it. This went from 4/4, that's that, to 3/4, okay? All right. Now, this guy, p is going to equal, actually, let's see, if I divided both sides by 4, then I get -1/16. So that's even smaller, okay? So let's figure out where we are. We know that this guy also opens up downward. God, that's 4 in a row being down. That just seems stupid. All right. Well, I'm going to be careful on the test, so don't expect that. So now if my x is not going to change, so you can kind of see here that this guy, and this guy are not it. And I'm going to drop a full 16th from -6. Okay, so -6. So -6 is going to drop a 16th. So let's see. That's going to be a drop. So we're going to have -16 and 1/16. He's going to go one more towards -7, one click. So what is, I don't see -6 and 1/16. So let's go ahead and figure out. Let's turn this into an improper fraction by going 16 times 6 plus 1. I don't know why I put plus 7. I don't know why I put plus 1. What is going on here? Okay, 16 times 6. Okay, add 1. -97/16, and that is exactly what we have right there.